AVNIK Defense Solutions. I think the presenter is already here. Jonathan Hutchings, talking on optimal sensor placement strategy, on-platform sensor parametric readings, and everything's going to be mapped in 3D, correct?
Correct.
The scene is yours.
All right, thank you. My name is Jonathan Hutchings. I work for AVNIK Defense Solutions based out of Huntsville, Alabama. I'm a software engineer, so everything I'll be telling you today will be based from that perspective. I'm not like one of all you great minds out there working with sensors and that kind of thing. I'm a computer programmer. So, back in early 2014, AVNIK partnered with the U.S. Army in order to create a project called Optimized Structural Health Monitoring. Now, the optimized portion has to do with one of the requirements, which is try to use as few sensors as possible, but maintain a very high or get the maximum amount of sensitivity out of the system. Now, that optimized portion was done by a team led by Dr. Tom Knoll, and he will be giving a presentation on Thursday covering that section of the project. My section of the project concerns utilization. All right, once you have the data, once you have the sensor data, what do you do with it? Well, you have to translate it over into a situation or into information that the user can actually use. Well, when we started the project, we ended up breaking it up into 3 phases. What you're looking at now is the software that is at the end of phase 1, which is damage detection and localization. Phases 2 and 3 will consist of characterization, trending, and prognostics. This particular software had some very unique requirements in itself. For one, it has to work on a tablet because it's going to be at the actual structure. It's got several different types of users. You have the maintainer, you have the engineer, and you also have the logistician who has to utilize the data as well. And then they really hit me with a big requirement. It has to be written from the ground up, no third-party software, no licensed software, nothing. Everything you have to do from scratch. So my team and myself had built this interface, and what it does is it reads in this sensor data pulled in from the optimized sensor placement, and it performs the calculations based off the information that the PhDs had told us to put in. Once it calculates that information, it generates a green, yellow, red heat map that places on a 3D finite element model. Now again, this is supposed to work with the maintainer, the engineer, and the logistician. Well, what we tried to do is encompass not only a 3D finite element model, which you can manipulate just off the simple tablet by rotating, and you can zoom in, zoom out, and you can see where the damage may be. We also have a 2D layout, top, bottom, front, back, for an instant recognition of where they need to go look. And then we've got some other information down below. Now, the primary purpose of this is to save money on inspections, because one of the problems that the Army has is anytime they go into a specific type of structure, many of the hot spots where there be corrosion or cracks are usually obstructed by other parts. And many times during these inspections, they have to remove these parts in order to inspect behind them. We've seen demonstrations during this conference of those kind of problems. Well, this has to be done at the structure level, and it has to be done almost near real time. So the sensor data is collected, this is visualized. But what this program also does, one of the requirements, is it makes the model transparent. So if I can go in and I select transparency, I can go in and adjust the transparency so that way I can go in and see if there's any problems or any hot spots behind any kind of specific parts. That saves the maintainer from having to go in, take the parts out, inspect, and reassemble. During reassembly, you can also have a problem of introducing new problems. You go in and then you force to crack, or when you're looking for corrosion. So this saves time and money. And in many instances, these parts, you have to cut apart the structure and then sometimes re-weld. So that in itself takes a lot of time and it introduces more damage. So our whole situation here is just to get this into a format that the user can just look at, understand what's going on, and then eventually the final product will take the information, not only collate it at the maintainer level, but it will also go to the enterprise level where the logistician will start looking at this. So that way they can start looking at structures in groups of structures and fleets for that matter. So when they're looking at this, they can look at op tempo, which is where it's located, what its mission is, and also be able to correlate across different various structures to see if there are any common patterns and that kind of thing. That's it for me. Thank you.